All right, so time for the next session. I would like to welcome on stage Vladimir Pavlov and Alex Bakardzhiev. So they'll discuss how you can build and run applications cloud natively. It's a very important topic because nowadays, many of us have to deploy either on-prem on Kubernetes or in the cloud in, I don't know, Cloud Foundry, AWS or whatnot. So Vlad and Alex, I give you the word.
Thank you.
Yeah, thank you, Marto. Do you hear us well at the back? Okay, thanks. So thanks for coming to our session today. I know we are here just we are standing between you and the lunch. So I mean, technically, lunch is over there, so it's not there. But still, yeah, the next thing after the session is the lunch. So we'll try to keep it on time and not take more of your time. And also, just one disclosure to mention: there is actually no AI in this session. So if you've come to hear about AI, you're at the wrong place. And at the other hall, there is a session about AI productivity with my great friend Jonathan. So if you want to hear about AI, you can go there. We even tried to use AI to generate some of the images in our presentation. It failed. So absolutely zero AI-free session here. Okay, thanks. So I'm Vladimir Pavlov. I'm a senior technical product manager at SAP, working on our cloud platform with I don't even want to say how many years of experience, more than 20, let's say like that. And I have also my friend and colleague, Alex.
Hello, everyone. I'm Alexander Bakardzhiev. I work in SAP and cloud and build technologies. I'd like to talk to you today.
First of all, start with a brief overview of what are Buildpacks. By the way, how many of you are familiar with Buildpacks? Who have heard or used Buildpacks? Okay, quite a few actually, not so much, so many people. So yeah, then it makes sense to explain in a bit more detail what are Buildpacks and how they help your development lifecycle. Then we'll explain also the cloud native Buildpacks and their features and dig into more detail how they really help you to be more efficient and productive. And we will explain also how the technicalities of how they work, which is also probably interesting for those of you who want to dive a bit deeper. And we'll also demonstrate all of this with several demos. So let's not waste more time and go on. So Buildpacks overview. What is a Buildpack? Imagine that you have your application written in your favorite language. So we are at J prime, so obviously it's Java, right? Java. But it could be written in any other language as well. And in order for your application to be able to run on a cloud platform, it could be based on Kubernetes, it could be Cloud Foundry, whatever. The application needs to be transformed from your source code to some artifact that the platform can run, right? This also needs to happen in some kind of universal way because different languages, different frameworks, but the platform needs to have a unified way to run your application artifact. And this is actually what the Buildpack does. It transforms your application source code into a runnable image, let's say. It could be an OCI image, but different versions of Buildpacks, we'll talk about this, could run it into, could transform it into a different final artifact. But in the end, it's something that the platform can run your application. And so, for example, let's take a Java application. What does a Java Buildpack do? It would first of all prepare the JVM where your application will run on. It would analyze what dependencies your application has and provide those dependencies for you. Also analyzing what services you want to use from the platform of choice, and configure those services, bind them to the application so that your application can communicate and use these services. It would also bring a runtime environment for your application, be it a Tomcat or Tommy. It could even be a Spring Boot, but as we've seen yesterday at the raffle, Spring Boot is not so great, right? Sometimes. I'm not hating Spring Boot. I'm otherwise Java E guy, but anyway, different flavors, different tools are available. But yeah, this is the runtime that the application would use, and the Buildpack will also provide and configure this runtime. And finally, it would also bring the application startup command to launch your application. And this is, in short, what the Buildpack do. Also, if you don't specify what Buildpack your application or Buildpacks your application wants to do, the platform, for example, Cloud Foundry, but as I said, it could be any other platform as well, can automatically detect the appropriate Buildpack or Buildpacks for your application. In other words, we can say that the Buildpacks are an abstraction of containerization of your code. And container, as I said, just don't take it as a let's say in the narrow sense of a OCI container or Docker container. It's just on more high level the runtime environment for your application. This is where your application executes. Or we could also say that the Buildpacks are the contract between the applications and the platform or runtime environment. And maybe just a brief overview of how this all started. Almost 15 years, sorry. Yeah, this didn't work. Almost 15 years ago, it started the concept of Buildpacks with Heroku in their platform. And then Paketo also took it off as a concept in Paketo Cloud Foundry, and then in the open source community Cloud Foundry. But these two diverged in terms of implementation and some aspects of how the Buildpacks work. But in 2018, so also not so a bit long ago, let's say, as well, 7 years already, they decided to come together and to converge on this concept. And now they produce the specification for Cloud Native Buildpacks, which also was adopted as a CNCF project, Cloud Native Computing Foundation. And we'll see also why they are called Cloud Native in the course of the presentation. But yeah, this is just a quick historical overview. So let's look into the features of Cloud Native Buildpacks and where they really help you as application developers. So maybe the most important one is the so-called auto detection and image build for your application. What does it mean? You don't really need to write clumsy Docker files to build to create your image. The Buildpack or Buildpacks would automatically detect, based on your source code, what is needed for your application and put it into the final image that your application will be using for running. And also, it would be the minimal things that your application needs. So if you don't need anything, you won't have the mistake that you put it and it's just cluttering your image. The Buildpack will provide exactly what you need, and without any writing YAML files or whatever to create your image. So I think that's the most important thing that boosts your productivity and efficiency. in terms of focusing on your business logic, on your application code, without taking care of all the infrastructure. Then also important is the fast rebuilds of your code. So if you change something in your application, the build pack would take the cached version and would also only provide what is really needed on top as a Delta update. So this really also boosts the performance of your builds and producing the final runtime environment for your application. Easy customization, what does it mean? You can easily contribute. Okay, first of all, there's a lot of existing build packs already in the so-called Paketo project. This is maybe, let's say, the reference implementation for cloud native build packs for different languages, for different frameworks. But you can also provide your own build pack. If something is missing as a feature or functionality, you can provide it and easily plug it into the other build packs. So you can chain build packs together, each of them providing some whatever it takes care of, and contributing to the final runtime image for your application. And this is also really nice because you don't need to fork an existing build pack and make something, the changes in there, and then also care about the maintenance of the upstream, how you bring it down to your image. You can just have this Delta micro, let's say, build pack that contributes the missing functionality for you. Then also probably important also in terms of compliance and security is the feature to provide the software bill of materials, or SBOM, for you can easily inspect what your application uses in standard SBOM formats like CycloneDX or SPDX, Zift, and so on. We also see this in the demo. So you have the inventory of your application image, and can also run scans on that and all the compliance and security related activities. And also in the terms of compliance and security, you can easily patch OS level vulnerabilities in your application by simply changing the whatever, if there is a vulnerability in one of the something on the base what the application needs as a operating system or some base library, you can change that in the build pack, and that would be automatically put into all your applications that use this build pack. And also similar to that, you have governance over what your application, all your applications in your organization use. Again, by controlling what is available in the base images. We'll talk about these base images in a second. And by that you basically distribute and have a, let's say, allow list for what your applications can use out of this base image, depending on what you put into there. Okay, so any questions up to now? By the way, I forgot to say, but if you have any questions, you can ask us anytime. We can also have Q&A at the end. And as I said, even though we want to deter you here from lunch, we can stay also longer if you wish to discuss. Okay, then if not, I'll hand over to Alex now to show us how to stage an application with the Cloud Native Build Pack.
So imagine I'm an application developer and I want to stage my application. What does this mean? Staging a process of building an application from sources to an OCI image, and then in the demo we will run it in a cloud platform. But first we want to build our application locally and test it. So let's start. Here we have a very simple Java web application. It has one servlet It is built with Gradle, and the application is really very simple. When invoked, it just returns status code with some response. So we want to build that application, and we will use a tool, which is actually a command line interface. It's called Pack. It is useful for local development. With it, you can create images, create build packs, rebase images. But for now, we will only use to build our sample application into an image. And here we specify the builder, which we are going to use. It is do you see it now? Okay, so a builder is basically an image. It contains a list of build packs, it contains a life cycle, and it contains a base image. And of course, a reference to a run image. Life cycle is also important to know what it is. Actually, it is something that orchestrates the whole build process. It knows how to invoke different build packs that participate in the build, and knows how to determine the build pack order, the execution order of the build packs. And in our case, we use a builder which is based on Ubuntu Jammy Jellyfish. It contains a lot of tools in addition, but in your cases, it's not necessary to use it if you don't need all the tools in it. You can use a tinier one. This is also something cool in Cloud Native Buildpacks. So we here also say some parameters as well, but let's start this. I will just continue the, sorry. Oops, sorry. Okay, it's running now. It's downloading the builder. It is taking a while, and it is first detecting the different build packs that will participate in the build process. Here I stop it just to see the different build packs which are participating in the build. We see we use CA certificates build pack because we want to bring CA certificates in both build and run images. And then we use a submachine build pack because we have to have a JVM to run the application in. And the submachine build pack will download basically a GRE. If you're not familiar with submachine GRE, it's based on Ubuntu. Oh, sorry, it's based on OpenJDK. Then we have Apache Tomcat builder. It is actually also important because we want to host our application somewhere. So we will use Tomcat in our case, and I will pause it. There are also several other build packs here. We have listed there before. They are for generation of the software bill of materials Vlado mentioned before. Actually, it's a Zift build pack which brings the Zift CLI, and one more build pack. It is the Gradle build pack because our application is Gradle based, so we want to build it somehow. And okay, I'll unpause it again. So it is built, and we want to somehow test it. So we will use a Docker for that purpose. You know Docker. And we are starting a container out of the image. It has finished, and let's check on localhost if it is running. So it's running and returning simple status code. And yeah, basically this is it. You don't need to have to know all of the details how to build an image. You just concentrate on your business logic. And Vlado, now can you tell us how this works?
Yeah. Sure. Thanks for the demo, Alex. Okay, does it work? So let's basically summarize what we've seen and explain a bit more on the technicalities of how this works. It's maybe it seems a bit complicated, but the important thing to know is a few concepts. We have a lifecycle, we have a builder, and we have, on the next image we'll see, on the next slide we'll see the base and the run image. These are and the build packs, of course. These are the important players in the whole process. And as Alex said, the lifecycle is basically orchestrating the whole build process. And the most important thing is that, okay, it has several phases that it runs through, but the most important are the detect and the build phase, the detector and the builder, which calls the detect script and the build script for the different build packs which participate in this process. And the detect, when you call the detect on the build packs, each build pack will examine the application and say, okay, I have something to contribute to the final image, or I don't have anything to do with this application. So this is basically the selection of the build packs who work for or provide something for the runtime environment of the application. And the build script, or the build phase of the process, in this script, each build pack needs to really do the work that it needs to do to provide whatever it contributes to the final image. The other phases are even optional, so they also work with optimize a bit the process. For example, the caching, which I briefly mentioned in the beginning, to take whatever is present in the previous image and not build it again. So the builder is also the important concept. This is an image which contains in itself the different build packs that can be used potentially in the process, and it has the so-called stack, which is basically a combination of the build image and the run image. The build image is the environment where the whole build process executes. So this is what there is a command create builder if you want to build your custom builder, and this is the builder image that is produced at the end with the, let's say, 2 build packs, a lifecycle. This is the implementation of the lifecycle that we've just seen, and the build image where the build environment, which is the build environment for this process. And the run image is just let's say, a reference that the builder image knows, and it would be what your application would be based on. Application image would be based on, and we'll see this actually on the next picture. So here is how the building the application image works. Again, we have the builder image with the build packs, the lifecycle, and the build image. We have a builder image and the build image. The build image is the environment. The builder image is the bigger thing that somehow collects all the players in the process. You have your app, and in the build process, build step, basically the application image is generated. How? Each build pack contributes whatever dependencies or whatever it finds as configuration and so on into, let's say, some kind of directory. And this directory at the end is assembled into a layer into the final application image. So in the final application image, we have the build pack provided layers from the different build packs, and we have the application code, of course, and the base run image. So this is the base for all of your applications, which can be also easily exchanged, as I explained. If you need to patch some vulnerability, then only the base run image would be exchanged for all of your applications. And this final application image is actually what the platform would take and run. It can be run locally, as Alex just showed us. It can be run on a cloud platform like Cloud Foundry. It can be run on whatever container orchestration like Kubernetes can work with these images. So hope it's a bit more clear now how this machinery works. And Alex, maybe back to you for the next demo, how to build.
Actually, I just wanted to tell that we have the image, but we don't know what it is and what it contains. So there is useful command, at least from my perspective, that will I will demonstrate it. It's called inspect image, so we can just have a look at our newly generated image here. So it works, you just have to pass the name of the image, and here we see, for example, the base image. Do you see? Okay, here is the base image that we used, the run image, and then we see the different build packs that participated in the build and their versions. Here 8.5 is not the Apache Tomcat, but the version of the build pack. And we also see some details regarding the processes that will be run on the container created from that image. Okay, so this is it for the inspect image. Basically, Pack offers a lot of useful commands, and in addition, it is also a library. It's written in Go, so you may find it interesting. And here in our next demo, I just wanted to show you how you can deploy, meaning have a running application in a cloud platform. In our case, I want to use Cloud Foundry, and for in order to deploy the application, I will have to tell the Cloud Foundry some information about my application. If you're not familiar with Cloud Foundry, we use manifest files. So here we do see it. No, probably. In the manifest, tell, for example, name of the application, number of instances that we want to have running after the staging. Environment variables, we can also tell some configurations about memory settings and so on. And here we see again the list of the build packs is the same, but in this case the platform should somehow take the build packs, and in our case we use an artifact registry, which is GCR.io. But basically the list is the same. And another important thing here is that we use a lifecycle called CNB. It's recently introduced in Cloud Foundry. And if you want to use Cloud Native Buildpacks, you have to specify it here in the manifest. Otherwise, it won't take charge, because the Cloud Foundry will use the classical buildpacks for the deployment. Okay. And here, the deployment is very simple again. Sorry.
Well, while we're waiting for this, how many, just out of curiosity, how many of you know Cloud Foundry or using Cloud Foundry? Ah, so maybe also the same amount of people who are familiar with buildpacks. Cool.
And yeah, I have started it, and basically it is downloading some resources, then building some layers, and then it will try to instantiate the process that is hosting the application. So we now see that the sub machine is being downloaded. After that, we can see the different build packs that participate in the build. First, the detect phase is being executed, then the other phases, which are to restore some data from the analysis and then to produce the final image. Here, I think Gradle is building the application. Yep. And now the Tomcat is preparing. and now the export phase takes place. It is basically taking all the results from the base phases which the build packs produced, and it combines them into a final image. And after the image is made, the Cloud Foundry is taking care of spinning a new container and yeah, running the application. So yeah, it is uploading. Yep. Okay.
No, okay. This was still the building of the image, right? Or sorry. Oh, this is already the Cloud Foundry deployment, right? Yeah. So, do you want to answer?
Yeah.
You need the CF push. This is a command from Cloud Foundry. But this is just an example of how you can use the built image. You can also use it, for example, you can also deploy it on Kubernetes with Paketo. The CF is the CF push is the Cloud Foundry specific command line client.
But at one side you have to have the platform like Kubernetes or Cloud Foundry, and we will not talk about that. We will talk about how to build and run your application on a platform. So here the CF is just the CLI that we use to deploy on Cloud Foundry, right? And Pack is again CLI, but we will use it to deploy and develop locally in our environment. That's one of the benefits here in Cloud Native Buildpacks, because you can easily develop your application locally. You're not obliged to run it somewhere in cloud platform before it's mature.
So maybe just to separate just a sec, to separate into this. So Pack is the important thing that actually is used universally. So this is the thing that builds your application image out of your application code using all the build packs that are available, right? And then the CF, this particular demo is the an example of how you can make use of your image on a cloud platform like Cloud Foundry, which also actually orchestrates the build process, but that's more, maybe a bit more of detail here. But similarly, the produced image that we've seen in the previous demo, which Alex ran locally with Docker, could be also used anywhere where an image could be run. Yeah. I think there was another question.
Could you?
Can we be sure that does the build pack use multi-stage build, and can we be sure that in the final image there will be no Gradle related stuff?
Yeah, there are several phases, and you can even make your own build pack, but there are no Gradle stuff there. I mean, well, if your build pack brings some Gradle things into the final image, because it's using layering, right? So it depends what you put in that layer that build pack creates. If you put something that is Gradle related, it will be also in the final image. But basically, this is not the idea. The idea is to group the results from different build packs into something that is later used during the container spin-up. So I guess we can continue the demo and then discuss the details. Here, just we take the URL on which the application is accessible, and let's try it. Okay, here, yeah, it's accessible again. Yeah, it's returning a status code. So this is a call to the real application living in a Cloud Foundry platform. And I want now to show you how you can create a custom CNB. So for that purpose, we will use another command. It is called pack build pack new. Do you see it? Maybe not. Here we say the name of the build pack, the API version of Cloud Native Buildpacks specification, the path to our directory on the file system where the build pack will be stored, some versions, target platform architecture, and so on. I will start it and sorry. And it created several things. First, we see there is a directory called bin on a file system, which there are two things. Basically, these are executables or scripts in our case. And another thing which is called buildpack toml, which is a Tom's obvious minimal language format for basically this is the manifest of our build pack. We tell here the name of the build pack, ID, version, and so on, target architecture. And with the other, we can actually implement the logic of the build pack itself. I'll just unzoom and continue. Now we have to provide the real logic of our build pack. So first, the detect script. In our case, we will write it in bash because it's fairly simple. And we will use an environment variable. Let me show you. Just as a flag, whether we should participate in the build process or not. We want, with that build pack, to provide, let's say, OpenTelemetry jar to a file system of the application VM. So we get, we somehow have to get this artifact and then put it in the image so it can be used later in the container. And this is just a flag for us to participate.
So you see that the detect script is very simple in this case. It just sees whether this environment variable is present and decides, okay, if this is present, I will participate in the build process and provide whatever is needed in the next phase in the build, right?
Mm-hmm. Okay. Let me just show you what the build is. Actually, the build script or executable is doing the heavy lifting. It downloads artifacts, prepares environment, instantiating tools, whatever you need. So basically, we will do three things here. Do you see it? First, we will create the layer in which we will work. So we want to put OpenTelemetry jar there, so we will call it OpenTelemetry. So we create the layer directory. Sorry, with this unzoom thing, it's a bit hard, but I think you got the idea for the first step. And now the second step, we will download the OpenTelemetry jar into our directory. And then the third thing, we will make our newly available layer available for the rest of the process. So it will be, it can be used later during launch of that process. Here you see we write the launch parameter and we set it to true. So basically this is it. This is the creation of our build pack. And we are ready with it. We can continue. But we somehow are not ready with the whole thing because it should be tested, right? We will test it later, but here I want to show you another tool that we use just to see the content of the image, and it is called dive. Again, another CLI. So we will use that to inspect the content of the image that we have just built.
So for example, if you're, sorry Alex, if you're concerned about what is final in the image, but obviously, I mean, the build packs that participate in your build process would only contribute whatever is needed for your application. But if you just want to to make sure and understand what is put into the image. This is how you can one way to examine the built image.
Yep. First way was with Pak, with inspect image, and this is the other way. We can use dive for it. Here we see the layers of the image that we made, and also there is information for the things that each of the build packs contributed to the final image. Sorry. Let me continue. So here we browse in the left, and then we will go to the Open Telemetry. Here we see the layer of Open Telemetry, our build pack, and I will unzoom it in order to unpause it, and then at the right pane you can see what it is in the file system. Yeah, we see that in the test directory here. Sorry. Here in the test directory is the Open Telemetry Java agent jar that we just provide in the image. And basically this is it for dive. And now we have to test it, but how to test it? How to test our new build pack? Not in production. Okay, so we will just create another image, just an application that we want to deploy using our custom native build pack. For that purpose, sorry, but first another thing. Vlado mentioned the software bill of material. It's also an interesting part because somehow we need to just patch some OS vulnerabilities and need to check the version of some dependencies that we have. And here with Pak SBOM download, we can get the information generated during the build and check whether certain tool or dependency of ours has a vulnerability or not. And it is taking a while to download the results from the Zwift CLI. We'll see them in a minute or second. We will browse the layers directory here, and here we will see the content of what each build pack has as For example, we are using Spring Boot in that case. It brought cloud bindings as a dependency, so we want to check what is the version of cloud bindings that we use. And we see the version of Zwift that we used to generate, and we see, cloud bindings is 204 currently. I think.
And so this is basically, again, you can download the software bill of materials for your final image and use them in all for example, pass to your scanning process to analyze the dependencies. I'm not sure whether we would have time for the bonus demo because we have just 5 minutes, maybe later, and
okay,
we promise that we'll.
Are you interested in GraalVM as well? We just wanted to show you how it is integrated with Cloud Native Buildpacks. We won't get into much details into the GraalVM itself. Okay, so I will try to be as brief as possible. Okay, so here we can use GraalVM native builder by using a specific Maven plugin for it. We want to have a native image built by GraalVM. You know, actually there was a session yesterday, very nice session by Sebastian Deleuze. It mentioned GraalVM, but in our case, we want to just create a GraalVM native image with the use of Cloud Native Buildpacks. So here we have another simple application. It is using Spring Boot, but I just wanted to show you the POM XML configuration and the build plugin of Maven that we used. Okay, let's continue. By the way, it is going to build a custom image, and here, if you see, we don't specify the list of build packs because we are using the default builder, and in the builders, as we said, there are some build packs. So if you don't specify them, those from the builders will be used for detection. And now it detected that our application is Spring Boot based. It detected it's using actually it is we want to build it natively by this I will show you later flag, and it is also using some JVM in order to get some details out of it, because as you know, with GraalVM we work in closed world assumption. Everything should be known before the start of the JVM. So everything should be statically analyzed before running the JVM. And every class that is reachable should be analyzed before in order to build the final native executable. The details here are not so interesting. The interesting part is that you can have an application and you just instruct the build process that you want to use GraalVM native image with some parameter, and it will take care of the rest. It is a very slow process actually. For me it took 8 minutes for the whole thing to be generated, and having in mind that this is very simple application that has only one main entry point and nothing else, it's doing almost nothing. It's a lot. It's a really slow process. So for the sake of the demo, I have cut it a bit. And we see that it is running the static analysis. It's not so important for our case here, but we want to see the final result. And there are some advantages, of course. The startup time with GraalVM is almost nothing in comparison with the normal compilers. But of course there is some drawbacks like the slow build time, and also here I want to show you that with this automatic generation of the image, the plugin and the whole thing, the Spring Boot builder, that build pack that we used, it has automatically generated the configurations, because as you may know, in GraalVM and with AOT, you have to basically provide some configurations for the dynamic things like reflections or dynamic proxies, and even resources. If you want to use some resources, you have to provide some configuration for it in order to use them during the run. And here the configuration is created automatically for us. This is what I wanted to show.
How many of you are using GraalVM, by the way? Okay, not many.
Yeah, here is the configuration. I just pause for a bit. Yeah, it's about logback, but it's not so important for our demo here. And this is it from my side. So, Vlado.
Yeah, this was just an example also to see that there is even pre-existing, or let's say standard Paketo build pack for GraalVM, which can also be plugged into your build process and produce an optimized image which uses GraalVM at runtime.
Yeah, I have just started it. So did you mention how fast it was? It took 0.1 seconds to start.
Yeah.
In comparison with the first example, I think it is 2 or 3 times faster.
So this is the cool benefits of GraalVM. That's why I also asked how many of you are using GraalVM. And yeah, if you really need a application optimized for performance, yeah, GraalVM is probably one of the coolest ways to go there. Okay, maybe just to wrap it up then, because yeah, this is not, the GraalVM is not the focus of our presentation. It was just a bonus to see how you can also that you can actually also make use of it with Cloud Native Buildpacks as well. Okay.
So this was the demo. And
so yeah, as I promised, we don't want to keep you from lunch. Again, it's not behind us; it's the other way. But still, let's wrap it up. So I hope we've shown you that Buildpacks are, and especially Cloud Native Buildpacks, are a really powerful tool for your entire application lifecycle. You don't need to care about writing Dockerfiles and all the other stuff and all the benefits that we've demonstrated around that. So my advice is, if you need to transform your application into a runnable image on a cloud platform, something yeah, some platform that understands containers, please make use of it. There's already an extensive set of Cloud Native Buildpacks available in this Paketo project for different languages, not only Java, Node.js, and many others, many frameworks supported and scenarios. So the chances are high that whatever you need is already available there. Cool thing, it's open source, and it's also very easy to write your own Cloud Native Buildpacks. We've seen the example with OpenTelemetry. It's a simple detect phase, simple build phase that just downloads and configures whatever is needed to use OpenTelemetry by your application. And it's also very easy to plug it together into the whole chain of Buildpacks. Two important resources. Buildpacks.io is the project space, let's say where the specification about Cloud Native Buildpacks is. And as I mentioned, Paketo is the space to examine all the many available already implementations of Cloud Native Buildpacks. So with that, thanks for coming.
Yep.
Sorry if we didn't kept on our promise to not take your lunchtime, a bit of it, but we are here if you have any questions or comments, or if you want to discuss anything. Yeah, thank you.